Hello, I'm Carlos Rosso Suarez, and this is the CRS channel. We're going to continue with our pre-calculus problems. In this case, we're going to work on a geometry problem. It says the following. For a circle circumscribed to a triangle, the product of the lengths of any two of the sides of the triangle is equal to the product of the diameter of the circle and the altitude traced to the third side. Prove this. Okay, for this problem we have three cases. One is the right angle triangle. So we have the circle circumscribed to a right angle triangle. Here, triangle AGB, with the right angle being the angle AGB. Second case is the acute angle triangle, which is the triangle BGA. And the third case is the obtuse angle triangle, which is the triangle GBA, which the obtuse angle is the angle AGB. Now, as you can notice, for the right angle triangle, you can see that it is inscribed in a semicircle. Remember the previous exercise in which we proved that the inscribed angle in a semicircle is a right angle. For the acute angle triangle, you can see that the triangle occupies part of both halves of the circle. The right angle triangle occupies one half of the circle. And for the obtuse angle triangle, the obtuse angle triangle occupies less than half of the circle. Okay, so let's look at the first case, which is the right angle triangle. Here we have that if we choose two sides of the triangle, let's see, start choosing one of the catheti. In this case, let's choose cathetus GB, and we choose the hypotenuse, which is AB. Length of GB is lowercase a. Length of the hypotenuse is C, which is also equal to uppercase D, which is the length of the diameter. Because the length of the hypotenuse is the length of the diameter, because AB is the diameter of the circle. The center of the circle is at C, uppercase C. Okay. So, if we choose A and C, or A and the diameter of the circle, if we multiply A times D, then it should be equal to the altitude traced to the third side times the diameter of the circle. Now, what is the third side? The third side is simply side or cathetus GA, with length equal to lowercase b. So the altitude traced to this third side is simply the side or the cathetus GB, or A, or lowercase a. So that means that AD equals AD. That is, the product of the two sides, which is AD, is equal to the product of the height or the altitude traced to the third side, which is A, times the diameter of the circle, which is D. Okay, the same result is, or the same type of result, it can be obtained if we choose the two sides being GA, or that is B, or lowercase b, and lowercase c, which is D, which is the diameter of the circle. So product of GA times AB is simply lowercase b times lowercase c, which is equal to uppercase D, which is the diameter of the circle. So it's B times the diameter of the circle. Now, which is the third side? The third side is GB, which is lowercase a, and the altitude traced to that, the third side, is simply GA, which is B. So the product of the sides is simply the product of the altitude times the diameter. Okay, now let's assume that now we're going to take as the two sides of the triangle sides GA and GB. That is, we're going to have the product of A times B. Okay, so the altitude, that is the first, let's consider which is the third side. The third side is simply the hypotenuse AB. So the altitude traced to that third side is simply the segment GE, which is denoted as H sub C. I'm going to simply call it HC. Okay, so we know then that the sine of the angle beta is equal to HC over A. But the same sine, or the sine of the same angle, is also equal to BD, or B over D. So the sine of beta equals HC over A, and it also equals B over D, or B over the diameter, which is B over the hypotenuse of the triangle. So we have then that B over D equals HC over A, which means that A times B is going to be equal to HC times D. And in this way we have proved then that for the right angled triangle, the product of the lengths of any of the two sides of the triangle is equal to the product of the diameter of the circle and the altitude traced to the third side. Okay, now what happens if we have the acute angle triangle? That we will solve in the next video.